Thunderstorm ingredients and how a thunderstorm becomes severe. We've all watched the beauty of a thunderstorm on a summer night, and the lightning certainly can put on a beautiful show, but really what are the ingredients necessary to develop a thunderstorm? There are three. We'll look at them one by one. The first is moisture. Now, although we're surrounded by the Great Lakes, and you would think that the Great Lakes would be the moisture source for thunderstorm activity, actually the primary source for thunderstorm development with regard to moisture comes from the Gulf of Mexico and the Atlantic Ocean. This is the primary reason why our thunderstorm season in northern Michigan usually does not begin until later in the spring, if not summer months, because it takes that long for some of that deeper moisture, more humid air from the south to work its way into the Great Lakes. The next ingredient for thunderstorm development is instability. What is instability? Instability, in simple terms, is warm air at the ground that wants to rise. Warm air is less dense than cold air. We know this because if you have a fireplace or a wood stove, where does the heat go in the room? Well, it goes toward the ceiling. The same thing happens in the atmosphere. The sun comes out, it heats up the ground, that air near the ground warms up. As it warms up, it's less dense, it wants to rise. Eventually, as it rises, it cools to a point of condensation, you get a cloud and the beginnings of a thunderstorm. That is instability. The third ingredient, in addition to moisture and instability, is lift. Now, there are many different ways that we can lift air in the atmosphere. It could be along a frontal boundary, it could be a lake breeze boundary, it could be a leftover boundary from a previous day, it could even be a hill or mountain that forces air to rise. Once again, as mentioned previously, as air is forced to rise, it cools eventually to a point of condensation, and this is the beginning where you get a cloud and eventually possibly a thunderstorm. Now let's look at the thunderstorm life cycle. There are three stages to a thunderstorm life cycle. The first stage is called towering cumulus stage. This occurs generally during the morning hours into the early afternoon, where you begin to see some cotton ball cumulus clouds, and this stage is driven entirely by warm rising air. We're going to call that rising air an updraft. As that air warms at the surface, it becomes less dense, it wants to rise, it reaches a point of condensation, that is the beginning of our cloud, and if it continues to rise, that cloud will grow vertically over time, and it will become what we consider to be a towering cumulus. Now, if the storm grows large enough and that rising air is sufficient to continue to build the cloud, we'll get to the point where precipitation develops within the cloud. That enters us into the mature stage. When precipitation develops within the cloud, we now have sinking air associated with the rain. So we have rising air, which is feeding the thunderstorm, and that's the updraft. We now have sinking air associated with the rain. That's what we'll call a downdraft. When we have rising and sinking air occurring in concert with one another, that is the mature stage of a thunderstorm. This is also the most likely stage when we would see lightning and hail and wind gusts with the thunderstorm. Now, does a thunderstorm maintain itself at this middle stage of mature stage? No, it does not. Because as the thunderstorm begins to rain, it cools the air around the thunderstorm, effectively cutting off the warm air that was feeding the thunderstorm in stage one. Once that cold air surrounds the thunderstorm and the warm air is cut off, the thunderstorm is dominated primarily by sinking air associated with the rain, and the thunderstorm rains itself out. This is the final stage, the dissipating stage. There can still be lightning and some severe weather at this final stage, even as the thunderstorm is in its decaying stage. Okay, so that's a general thunderstorm, and they can produce some severe weather, but it's usually short-lived, relatively weak. What is the key factor for long-lived severe thunderstorm development? That's something called wind shear. What is wind shear? Well, wind shear is a change of wind speed or direction with height. Maybe it's easier to see on an actual picture of a thunderstorm. Looking at this picture right here, you can see winds at the ground are blowing from the southeast at 20 miles per hour, and at 5,000 feet are from the south at 50 miles per hour. You can see that's a change in wind speed from 20 to 50 miles per hour and wind direction from southeast to south. Why is this important? Well, a change of wind speed or direction with height causes the thunderstorm to become tilted. If you remember back to the previous slides, we were at a mature thunderstorm. when we have updrafts, rising air, and downdrafts, sinking air, occurring in concert with one another, we're at the mature stage. But if the thunderstorm is straight up and down, those two processes of rising and sinking air really conflict with one another, because the sinking air associated with the rain falls into the nice warm rising air, which is feeding the thunderstorm. They work against one another. But if you tilt the thunderstorm because of that wind shear, you can actually allow the thunderstorm to continue to be energized by that warm rising air, and also have rain-cooled sinking air occurring together and for a longer period of time, and they don't conflict with each other nearly as much. So what wind shear does is it tilts the thunderstorm, and it allows updrafts and downdrafts to coexist for longer periods of time, resulting in well-organized, long-lived convection, which can lead to severe weather.